Welcome to rebuilderinabox.com. Today we're going to be disassembling and eventually reassembling a 1940 Packard out of a straight 8-cylinder. I consider this to be particularly interesting because it appears to be original. Here we have the number MAW 4018, and I can tell by the solenoid with this auxiliary push button as a ignition switch bypass. Ignition switch goes here, battery goes here, and then when you push this button or hit the key or push the button up inside the vehicle, it transfers the voltage from the battery to here to go down into the starter. And by the fastener right here on the side, this flat round head and the square knot on the bottom, it appears, in my opinion, to be original equipment. First thing is we're going to do is we'll take these two screws out holding the solenoid on and take this connector strap off, and I'm also going to unscrew the band so we can see inside the starter. So we got everything off here. We're ready to pull the 4 brushes out. 2 are hot, 2 are ground, of course. The tool we're going to use is this magnanimous bent up coat hanger. Just hook it under the brush wire, and when you pull up, pull away from the spring. The spring's over here sitting on the brush, and there you can see the brush. So we're going to pull all 4 of them off, and they're barely worn. So this particular vehicle, this Packard, has been sitting around a lot. Now that we have all 4 brushes out, you always want to take those out before you try and take anything else apart. It's a lot easier. We're going to move forward and take out the 2 through bolts holding the back plate on. Actually, it's holding the whole thing together. So we took the 2 through bolts out. What you want to do next, just to pop this off, is give it a little bit of a smack. And it comes right off. There's a metal spacer on the back, actually a metal one and a paper one, that go right on there. And then here you can see the bushing, which has an oiler on it, and the 4 springs. 2 of these are hot. They have the insulators in, and just like a Ford, a 70s Ford starter, these can get loose, so you want to make sure that there's no play in those brush guides. And we're going to hold on to the housing and tap it apart. And this is exposing the armature right here and the field housing. So we got this sitting up on end a little bit. A lot of these intermediate plates, like an extra plate on the inside that's midway in between the front and back bearings, are screwed down. However, this Prestolite design doesn't have that. So we just kind of hold up on the armature and tap on the nose cone, the drive-in housing, until it pops out. So you can see the intermediate plate here, and this is the Bendix. This is why they originally called it a Bendix. As it turns, this is on a worm, and the spinning makes it go out. Then after the flywheel achieves a certain speed, it throws it back in. This big spring, which this side's fixed to the shaft and this side's fixed to this assembly, acts as a buffer or a cushion, so that when it doesn't have like a hard hit when it goes into the flywheel, it flexes on the spring a little bit. So we're going to test the 2 components. We're going to use an ohm meter. Right there is continuity. and then when you touch something that doesn't have any continuity, it'll move a little bit because the ohms is set so high. It's set up at 10,000 ohms. But this old stuff, all you really need, what we want to show on the armature here is we want to see that it's not doesn't have any continuity from the commutator and all the wires connected to the commutator to the frame. So when we touch these two, there's a little bit of continuity, but that's negligible. Full continuity would be all the way over. Okay, and then on the field housing, we have the brushes not touching anything. So you put one side on the hot post, and then as you touch the ground brush, it should be open. Then when you touch both hot leads, both hot brushes, they have continuity. So the field housing is good and the armature is good. There's no continuity between the fields and the case, and over here there's no continuity between the commutator and the case. So the other thing we're going to do that could possibly be wrong with this is we'll check for drags. In other words, one of the bushings, which some people refer to as bearings, wore out and allowed the armature to flex inside of the housing, and it would leave drag marks on the armature itself. And what would happen is you would see drag marks all over, pretty apparent drag marks all over the inside of these laminations, and that's a bad thing because the laminations can get pushed over and ground out the windings. Also, you would see drag marks. You want to inspect the inside of all 4 pole shoes to make sure that there's no grindings or shavings or drag marks on the inside of the starter. And this one doesn't have any. If there are drag marks, then you can go back and check the bushings for play, which that's going to have no play at all. It's super tight. You know, if you get like a lot of wobble there or something, but that's completely tolerable. This bushing here, trying to wobble it back and forth, doesn't have any play. And this bushing here on the back, it's got very little play. This starter itself has probably never been apart, and it's probably got very, very low mileage on the vehicle. So what we're going to do is these are the 3 products that I recommend to use. We're going to clean it up with CRC electromotor cleaner, and then this is going to be for the armature. We're going to paint the whole armature and then spin it on a lathe, or you could just use sandpaper and clean it up because there's no low spots on it. You would see arcing and problematic bars, and these are all clean. So we're going to paint the whole arm. We're going to clean it with an electromotive cleaner, spray paint the whole body and everything, especially on the lambs and down inside the windings, and try not to get any on the commutator, but if you do, it's not a problem because you're going to sand it off a little bit with 80 grit paper. And then this, after the fields are cleaned very carefully, because they're just a cotton wind back in those days, let it dry really well, which is why I recommend this product, and then spray the whole inside with red insulating varnish. These brushes are good. We would have to heat it up and open up the fields right in this area here. You heat it up, and once you see it start to melt, then you pry up, and that you'll be able to unfold that lead right there. Then you can get these brushes and replace them, put the new one in there, fold it back down with a pair of needle nose pliers like this, fold it back down, and then melt more solder back down in the sides. You would heat it up underneath and let the solder run down in that way. These brushes here, if you were going to change them, they just got screws going in the side of them. But this one here is going to require very little problems. Also, one thing that you want to check for is sometimes removal and installation and years of wear, whatever, the solder joint can go bad in the post, from the field leads to the post. So we take a screwdriver and tilt it sideways, and there's no movement there, there's nothing coming out, and you can look down in there and see that the solder is still good. It would be burnt up looking if it was bad. So we're going to clean that with the electromotive cleaner, let it dry, and then paint it with that, and then put everything back together. Okay, let's put this thing back together. Off camera we took the Bendix off. This goes on here first, and we're going to put a drop of oil on the shaft, a couple drops of oil on the shaft. Make sure there's no wobble. Off camera we took the Bendix off. What it is there's a keyway that goes right in there, and then you can see where the set screw goes in, which goes through this part right here. And what you do is get that lined up over top of it, and off camera we took the there's like this little keeper that acts as a lock washer that we took a little screwdriver and pried it off. And then when you get that back together, slide it on there so the keyway goes over top of that, so this goes over top of the hole that it goes in, and you can see the little piece on the end of there that goes down in this hole. So we're going to put that back together, and you can see the rest of the parts have been prepped. The armature has been varnished and polished, and the shaft was polished on the lathe, and we coated the inside with these. Just gave that a quick coat of paint to prevent rust, and we're going to have to put these spacers back on the top. What we're going to do is put some oil in here, because there's a piece of felt down in the bottom and it absorbs the oil, and you can also put some oil in the oiler, it'll wick down through. I like to have a little bit of white lithium grease in there as well. The nose cone has been buffed off a little bit, just get some of the surface rust off, because we're going to paint it. And then the inside's been coated with this red insulating paint just to keep internal corrosion out of it. The OE number and the tag we sprayed with clear. Then we're going to put grease on that before we paint the rest of it black, just to mask that off. The brushes here are still a little bit gunky, so we're going to take some acetone, put it on a rag, and wipe down the brushes with acetone so there's no residue on them when we put everything back together. So we got the Bendix all slid on here and the bolt installed. You can see how I stopped so that the flat side of the bolt is parallel to the locking tab, and you just take a pair of pliers and pull the locking tab up. That way it's locked into place. I've broke those before because they do break, and if you can find new ones, that'd be great. But if not, I've taken like a MIG welder or a TIG welder and just put a little dot on there. Or you could use a regular lock washer. It's kind of hard to get the thread started when you do that, maybe a star locking washer or something. I mean, the best thing is if you're able to reuse what they give you. We could go ahead and put the nose cone on while it's here. This has a hole in it, and there's a lineup pin right there. So just a little bit of grease and some oil, so the Bendix has some lube going in and out. Also should put a little bit of lube oil on the worm gears. And we'll just line that up and tap it on. So we got this down in here. It feels like a little bit tight. So a common thing would be to just tap it around a little bit as you're turning the armature by hand, and it loosens it up a lot. Be surprised how it centers. So we got a lineup pin here and a lineup pin here. Tap it down. Then a lineup pin here and a lineup pin here. We already put the spacers on. Then these go right through with new lock washers on them. It's a good idea to put some type of grease. We always use white lithium. Just drop them in and bolt them down. So we're ready to put the brushes in. Just take your brush tool, put that in your left hand, hook it on the spring, lift the spring up, and then stick the brush down in there. Sometimes you gotta wrestle it in, but they go right in. Okay, here you can see the spring centered on the brush, and then you want to take your tool and pull up on the brush wire so it can't rub the armature. So now we're going to put the band on. You can take, the factory has masking tape on there to try and keep water out, but you know, 1940s car, I don't think he's going to be driving it in the rain. I doubt if it's ever going to leave the museum. But we put this in already, and then you can put that where you want. Try and leave it, probably best to have this away from where the battery cable is going to go on. It might even go on this way. And then tighten that up, and you're pretty much done, except for installing the new solenoid, which is probably going to go like that, and then the new strap, which has been buffed up on a wire wheel. The newer the wire wheel is, the brighter you can get it. And then finish up. So to hook this thing up electrically, we're going to put a ground cable here, hot cable over there, and then when you click that, when you put juice to this, it closes the solenoid and puts juice down to the starter. So in other words, it would be just like sticking that on there. Okay, now we're going to do a little live demonstration so you can hear and see what it looks like when it's running properly. I have a foot switch hooked up so that when I step on the foot switch, it activates the solenoid. And you can see the Bendix come out, and then as it torques up a little bit, you'll see it move back a little bit. That's exactly what is supposed to happen, because the flywheel, after it reaches a certain speed, is responsible to throw the Bendix back. And there you have it. We're